Good morning students and welcome to online teaching session, and this is with continuation of the previous topics taught. Now let us see the important topic today, that is stoichiometry and stoichiometric calculations. This is the name of the topic. First, let us see what is meant by stoichiometry. Stoichion means element. Metron means calculation. That is the meaning. So, stoichion means element. Metron means calculation. This is the meaning of the term stoichiometry. Now we see one balanced equation, and in that how the reactants and products in terms of the quantities, means mass and volume, are correlated with each other. To understand the concept of stoichiometry, we will take the combustion reaction of an hydrocarbon, that is methane. Methane is hydrocarbon because it is made up of hydrogen and carbon. When this reacts with oxygen, it gives rise to carbon dioxide and water vapor. Here all the reactants and the products are in gaseous form. So here we have 4 hydrogen atoms. Towards right hand side we have only 2, so we will multiply entire H2O with 2. And oxygen atoms, altogether towards right hand side we have 4 and left hand side only 2, so we will multiply with 2 to balance it. So in that way all the elements are equalized or balanced on either sides. Now let us see what does stoichiometry speaks about this balanced equation. It speaks about number 1, the number of moles of reactants reacted to form specific number of moles of products in terms of moles. That is first point. Second point, in terms of molecules. How many molecules of the reactants lying towards LHS, left hand side, are able to form how many molecules of products towards right hand side. So in terms of moles and molecules over. Now let us see in terms of masses. Means how much mass of each reactant, or in terms of mass, the reactants are giving rise to products. What are the masses? These masses of reactants, masses of the products are correlated. And the last point is how much volume of each reactant reacted with each other, thereby to form how many volumes of the products. This is the information furnished by stoichiometry. Now let us see these one by one. First, in terms of moles. Besides CH4, nothing is written means by default it takes 1. That means 1 mole of methane. Is reacting with 2 moles of oxygen gas, right? Thereby to form 1 mole of carbon dioxide and 2 moles of water vapor. Here the reaction requires initiation, that is 1 spark of energy. So we can write here delta. Right. So 1 mole of methane is reacting with 2 moles of oxygen. MOL is abbreviation of MOLE. To form 1 mole of carbon dioxide and 2 moles of water vapor. So in terms of moles, reactants and products of this balanced combustion reaction are correlated. Now let us see in terms of molecules. In terms of molecules, if you take 1 molecule of methane is reacting with 2 molecules of oxygen gas. O2 is molecule, O is atom. So here O2 is molecule, means 1 mole of methane is reacting with 2 moles of oxygen gas, thereby to form 1 mole of carbon dioxide and 1 molecule of carbon dioxide and 2 molecules of water vapor. So below methane we can write 1 molecule. Below oxygen we can write 2 molecules. Means 1 molecule of methane is reacting with 2 molecules of oxygen gas. That is the meaning. As a result, we will get products towards right hand side in this way. That is 1 molecule of carbon dioxide and the other product is 2 molecules of water vapor. So in terms of moles, in terms of molecules, they are correlated. Now let us see in terms of masses. Methane, if you take carbon mass 12, 4 hydrogen atoms, 4 grams, altogether 16 grams. And oxygen, 1 oxygen atom, 16 grams. Like that we have 4 oxygen atoms into 4, 64 grams. So 16 grams of methane, that is third point in terms of mass. So molar mass of methane is 16 grams. 16 grams of methane reacts with 64 grams of oxygen. 64 grams molecular oxygen to form carbon dioxide and water vapor. Here molecular mass of carbon dioxide is 44 grams. 44 grams of carbon dioxide. 2 moles of water vapor. So 1 mole of water vapor weighs 16 plus 2, 18 grams. 2 moles, 18 into 2, 36 grams of water vapor. So 16 grams of methane equivalent. It will be 64 grams of oxygen gas. And the last point is in terms of volume. And here 1 mole of any gaseous substance, whether it is element or compound, it occupies 22.7 liters of volume. So here all 4 substances are gases. Methane is gas, oxygen is gas, carbon dioxide gas, water vapor is also gas. The only thing is we have to see how many moles of each reactant is there. Okay, if you take methane, its quantity is 1 mole. So 1 mole of methane occupies 22.7 liters of volume. So 22.7 liters of methane. It reacts with 2 moles of oxygen. 2 moles of oxygen means 2 liters, 22.7 liters into 2 of oxygen gas. So 22.7 liters multiplied by 2. 2 stands for number of moles of oxygen gas. So 1 mole of oxygen gas occupies 22.7 liters. That way 2 moles of oxygen gas means 22.7 liters into 2 of oxygen gas. Now towards right hand side we have 1 mole of carbon dioxide. So 1 mole of carbon dioxide formed occupies 22.7 liters of volume. And 2 moles of water vapor. 1 mole of water vapor occupies 22.7 liters. That way 2 moles of water vapor means 22.7 liters multiplied by 2 of water vapor. That's it. So that's about the relationship between the reactants and the products in terms of moles, molecules, mass and volume. Now based on this we have calculations called stoichiometric calculations. Before going to discuss the stoichiometric calculations, let us see the relationship between the mass of the substance, here substance means it can be reactant or the product, and volume of the substance, and also the one is mass of the substance, number 2 volume of the substance, and number 3 the particles, that is molecules of the substance. These 3 are correlated with each other. Here in this equation, second point, that is in terms of molecules. 1 molecule of methane is reacting with 2 molecules of oxygen gas to form 1 molecule of carbon dioxide and 2 molecules of water vapor. It is written. If we take in terms of moles, 1 mole of methane contains Avogadro number of molecules in it. 2 moles of oxygen gas contains 2 into Avogadro number of oxygen molecules in it. So also in the case of carbon dioxide and water vapor. So correlation can be shown in this way. Molar mass of the substance can be correlated with number of moles of the substance and that Avogadro number of particles. Here particles means molecules in this case. So here they are correlated in this way. So based on this correlation, numericals can be set. And we will see some sample numerical over molar mass, moles and Avogadro number of particles present in it. This is called sample numerical. Made in mole and molar mass are correlated with each other. It can be like this. Calculate the mass of the following. Number 1, 0.5 mole of NaOH, and number 2, 0.25 mole of carbon dioxide. These are the two reagents. Reagents means chemical substances. And here we are required to convert the mole into mass. For that we need to know the molar mass of each substance. Molar mass of any substance is equal to 1 mole of that substance. Right. Now let us see first one. That is 0.5 mole of NaOH is equal to how many grams? That is the summary of this numerical. Here 1 mole of NaOH weighs 23 plus 16 plus 1, 40 grams. Right. And it is asked to calculate 0.5 mole of NaOH weighs how many grams? So 0.5 means half mole. 0.5 mole of NaOH weighs 40 into 0.5, that is 20 grams. So half mole of NaOH weighs 20 grams. This can be asked in MCQ. Option A 20 grams, option B 2 grams, option C 0.20 grams, option D 40 grams. So out of those 4 options you need to prefer the correct option. Now we will move to the second part of this numerical, that is 0.25 mole of carbon dioxide. So 1 mole of carbon dioxide weighs 32 plus 12, 44 grams. And yes children, now come to the second part of the numerical, wherein the number of moles of a particular compound weighs particular grams. When we take less than 1 mole or more than 1 mole, how many grams that substance is going to weigh? That is what we are going to calculate. So 1 mole of carbon dioxide weighs 44 grams. Here 44 grams is molar mass of carbon dioxide. So therefore 0.25 mole of carbon dioxide weighs how many grams? So 44 multiplied by 0.25. So half of 44 is 22. Again half of 22 is 11 grams. So 0.25 means 1 by 4 part of 1 mole. So 0.25 mole of carbon dioxide weighs 11 grams. In this way, number of moles and the weight of the substance are correlated. Now we will move to a different type of numerical wherein the molar mass and the Avogadro number of particles are correlated with each other. In that, let us see 2 samples. We can take one in the case of element and the second one in the case of compound. First, let us see in the case of element how its molar mass and the number of particles present in it are correlated. So here correlation is between molar mass and Avogadro number of particles. Here particles means they may be atoms. If it is element, right, or they may be molecules if the substance is compound. We use the term molecule even in the case of element if it is made up of 2 atoms of same type. That is diatomic molecule or tetraatomic, alpha-atomic and so on. Now let us see the numerical which is based on this relation. So sample numerical. It can be like this. Convert the following. 2 grams of carbon monoxide molar mass. Calculate the number of molecules present in 2 grams of carbon monoxide and 4 grams of glucose. Here carbon monoxide and glucose both are compounds. Let us see one more example wherein we can have element, that is say 0.35 grams of nitrogen gas. Here nitrogen means N. Nitrogen gas means N2. And molecular formulas of these compounds are like this: carbon monoxide CO, glucose C6H12O6. Nitrogen is empty. Now let us see the solution part. First one, 2 grams of carbon monoxide. Here molar mass and Avogadro number, they are correlated. That's what I told at the beginning. So the molar mass of carbon monoxide. Carbon is 12 grams in terms of grams per day. Oxygen is 16 grams. Means molar mass of carbon monoxide is 28 grams. So 28 grams of carbon monoxide. 28 grams of carbon monoxide contains. So here 28 grams is molar mass of carbon monoxide. So this contains Avogadro number of carbon dioxide molecules in it. Contains 6.022 into 10 raised to 23 number of carbon monoxide molecules. And here it is asked to calculate number of molecules in 2 grams of carbon monoxide. So if we know number of molecules of carbon monoxide in 1 gram, we can calculate in 2 grams. So therefore, here we can calculate the number of CO2 molecules in 1 gram, or 1 gram of carbon monoxide contains how many molecules? That is 6.022 into 10 raised to 23 divided by 28 molecules of carbon monoxide. Therefore, 2 grams of CO contains. So whatever number we are going to get here after division is multiplied by 2. That is 6.022 into 10 raised to 23 divided by 28 multiplied by 2. Molecules of carbon monoxide. So cancellation to be done. The method is based on the molar mass of the substance and Avogadro number of particles. And if we move to the second part, that is 4 grams of glucose contains how many glucose molecules? Molar mass of glucose is 180 grams. Means 180 grams of glucose contains Avogadro number of glucose molecules in it. 180 grams in solution of B numerical. 180 grams of glucose contains 6.022 into 10 raised to 23 number of glucose molecules. Therefore, 1 gram of glucose contains how many glucose molecules? So 6.022 into 10 raised to 23, that is Avogadro number, divided by 180 glucose molecules. Therefore, so it is asked to calculate number of glucose molecules in 4 grams. Therefore, 4 grams of glucose contains 6 6.022 into 10 raised to 23 divided by 180, that is molar mass of glucose, multiplied by 4. Number of glucose molecules. This you can simplify. And if we move to the third part of the numerical, that is 0.35 grams of nitrogen contains how many nitrogen molecules? 0.35 grams. Here molar mass of nitrogen gas is required. Then only we can correlate it with Avogadro number. So nitrogen gas means N2. So molar mass of N2 is nitrogen atom weighs 14 grams and N2 weighs 28 grams. So that way we can correlate it with Avogadro number. 28 grams of nitrogen gas contains Avogadro number of nitrogen molecules. So 6.022 into 10 raised to 23 number of nitrogen molecules. Now from this we can calculate 1 gram of nitrogen gas contains how many nitrogen molecules? That is 6.022 into 10 raised to 23 divided by 28 grams of nitrogen gas. This leads us to particular number of nitrogen molecules. Therefore, it is asked to calculate in 0.35 grams. Therefore, 0.35 grams of nitrogen gas contains how many nitrogen molecules? So 6.022 into 10 raised to 23 divided by 28 multiplied by 0.35 nitrogen. This we can simplify. So that way, number of moles of a given substance and its mass in terms of grams. At the same time, the molar mass of the substance and the number of particles present in it are correlated, and in that way the numericals can be framed. So that's about stoichiometry and stoichiometric calculations. With this first chapter, that is some basic concepts of chemistry.